Alright, let's start on the intus. Into question number 4. Largest molecule with the largest dipole moment. When you look for a dipole moment, it means polar. Who's going to be the most polar? The correct answer is water. Why is water going to be the most polar? Because it's got an oxygen, hydrogen, oxygen, hydrogen. It's got 2 lone pairs of electrons, and water is just known as a very polar molecule. A is, you need to know A, carbon dioxide is nonpolar. C is nonpolar, it's methane. Anything with carbon and hydrogen only is going to be nonpolar. The only other situation is going to be pH3. When you draw a Lewis structure for pH3, that's what you end up with. It only has 1 lone pair of electrons, and the electronegativity difference between oxygen and hydrogen bonding is greater, so it's going to become a more polar molecule. Next one, 12. A reaction that produces a coordinated complex. A coordinated complex is when you take a transitional metal and you wrap it around a bunch of ions. So there, right there, if you notice, you have platinum, which is a transitional metal surrounded by a bunch of ions with a charge. That's what a coordinated complex is. So a coordinated complex is going to be on the right-hand side. It's going to be a transitional metal surrounded by a whole bunch of ions. Pretty easy to spot. In fact, you'll do the reaction homework probably tonight if you're watching this on Wednesday. Combustion reaction was also requested. Combustion reaction is any time you take O2 and you combine it with other nonmetals. O2 combined with other nonmetals produces a nonmetal oxide. Normally used to combustion reactions like CH2, CH4. Well, in this case, if you look up here, B is a combustion reaction because you're combining oxygen with a nonmetal, S8, and producing a nonmetal oxide. That's the most complex definition of a combustion reaction. So a combustion reaction is O2 combined with other nonmetals, producing a nonmetal oxide. B is the correct answer. Question 15 was requested. Remember, this is a phase diagram. They tell you the substance changes from a solid to a liquid to a gas. This is going to represent solid. This is going to represent liquid, and then the gas is not shown on this point. It is a heating curve. So you have to make sure you read this and look at it. Its substance is at its normal freezing point. Remember, freezing occurs when you go between a liquid and a solid. The flat areas on this represent phase changes. So this first area right here represents melting when you're going from a solid to a liquid, or freezing when you're going from a liquid to a solid. So the correct answer is T2, because the first plateau is either freezing or melting depending on which direction you're going. If you're going to the right, it's melting. If you were going to the left, it would be freezing. The second plateau represents when you have a liquid going to a gas phase change. The next question they asked you, 16, was what best describes what happens between T4 and T5. So if you look, A is the correct answer. Molecules are leaving the liquid phase. If we come back to the diagram, if you notice, what's happening is it's going from a liquid. A gas would be on here. They don't show the line. But as you're heating it, its flat area is the phase change, is going to represent a change from a liquid to a gas. So 16, you need to know the parts of a heating curve. The flat areas represent phase changes. 17, what's the definition of isoelectronic? Means they have the same number of electrons. How do you figure this out? You use your periodic table. You're going to take the atomic number, and whatever the charge is, you're going to add the charge to it. So for example, or actually, I'm sorry, subtract the charge from it. So for example, if you take sulfur, the atomic number of sulfur is normally 16, or is 16, right? So 16. The charge on sulfur is -2. So that minus the charge, negative minus the negative, is going to end up as 18. So it has 18 electrons. Potassium. Potassium, K, normally has the atomic number 19. You're going to subtract a positive charge, or just take an electron away, means that it has 18 electrons. The last one is calcium. Calcium normally has the atomic number 20. It has a +2 charge, which means you Subtract 2 from the electrons because of the positive charge. So if it's positive, basically you subtract. If it's negative, you add. Think of it that way to the atomic number. So in this case, I have 18. So the fact that all these have 18 electrons means that they're isoelectronic. So to find an isoelectronic atom, all you have to do is take the atomic number and do the opposite of whatever the charge is. That should be pretty easy. 20. They asked you to find partial pressure. Partial pressure, remember, is based on Ruold's law. They always have this on the exam. It's going to be total moles on the bottom. So total moles on the bottom, and the part that you want on the top. Part of the moles on the top. So if you look here, I have 0.25 plus 0.5 plus 0.5. My total moles is 1.25. Then the part that I want, the partial pressure, is for SO2. So I take the moles of SO2, which is going to be 0.25. I put 0.25 on top. Then I multiply. Remember, Raoult's law is mole fraction times pure pressure, or total pressure, equals partial pressure. So they told me the total pressure is 800. So I'm going to take 800, put 800 down here, multiply times 0.5 over 0.125 over 1.25, which technically is going to be 1/5. So what is 1/5 of 800? Well, 1/4 of 800 is 200. Think of it that way. So 1/5 of 800 is going to be 160. So all you have to remember is basically mole fraction. You're going to use mole fraction for this. Total moles on the bottom. They're going to have you do this on the test. I take all these, I add them up. I take the part of the moles, which is going to be 0.25 on the top. I end up with 1/5 times 800 is what I'm really trying to do from a mathematical standpoint. Next one. In the library, how can we produce H2 gas? In chemistry, the way we do it is we react it normally with a metal. We either take magnesium plus HCl to produce the gas, aluminum plus HCl, these are all single replacement reactions, or zinc plus HCl in a laboratory. That is how we typically generate gas. Now, they're asking you which one can be produced. Well, you know HCl, if you react it with NH3, is an acid-base reaction. We've been doing reactions and writing them out. You should know that there's no gas produced. If you go net ionic, it's H plus NH3. The weak base is shown together. You get NH4. There is no gas. Therefore, whenever we have Roman numerals, when you can eliminate one, if you know one is not an answer choice, that means A is gone, D is gone, and E is gone. The other thing you should know for this question, you need to write down, is whenever you react HCl with something that has a carbonate in there, the gas that is produced is CO2. So that means Roman numeral 3 cannot be your correct answer, which B is, because in a laboratory setting, those are typically the three ways you generate hydrogen gas. Nuclear question. There's typically one nuclear question on the test. All you have to do is like regular balancing reactions, you have to make sure both sides are equal. So if I look from the point of view as far as this goes, the protons are listed on the bottom. So if I take 0 plus 92, this side has 92 protons. 235 plus 1 neutron is going to be 236. So then the other side of the arrow has to be equal to 92 and 236 as well. Well, I have 55 and 0, so to figure out what x is going to be, I just take 55 minus 92, because I know this thing has to equal 92, because both sides of a nuclear equation have to balance. So 55 minus 92 is 37. That's my number of protons, which leads me to make the, or figure out the idea that it's either got to be C, D, or E. Can't be this or this with 35 protons. Next thing, the top has to match. See how this is 236? Well, if I look right here, I have to total this side. I take 141 plus 3. Why 3? The coefficient in front of there is 3 times the 1. That's what most people get stuck on. So if you take 141 plus 3, you get 144. So then you have to take 236 minus 144 will tell you the number, the mass number of the unknown element, and that's going to come out to be 92, and that's what makes the correct answer. So all you have to remember when you go to do nuclear equations is the totals on each side have to match. In this case, you have 92 protons on this side, means you have to have a total of 92 protons on that side. That's how you can figure out the atomic number for that is 37. Okay. Next one. Simplest formula of compound. When we go to do this, the first thing you need to do is you need to take all, this is just an empirical formula calculation. So what I do is I take 1.0 moles of K, 0.55 moles of Te, and 1.65 moles of O. What we do when we do these problems is we divide by the smallest number of moles. So 0.55 goes under here. That was the K. 0.55 divided by 0.55. That was the Te. This is the Te right here. This pen's not working. And then the oxygen was 165 divided by 0.55. Okay. So then when we do this, this is obviously going to be 2. So automatically it starts with K. You limit to C or D. This divided by this is going to be 1 Te. And then finally 0.55 goes into 1.65. How many times? It goes in 3 times. That's why it's the correct answer. So remember, when you have to find a simplest formula, it's empirical formula. If they give you this on the multiple choice, the numbers have to be very easy. You divide by the smallest number of moles, you get the whole number ratio, which is 2, 1, 3, which is the answer for C. All right. When you go to enthalpy change, remember it's products minus reactants. So they give you the delta HF right here. Product is C6H6. C6H6 is right there, so I take 83. I'm done with my products. Minus, and then I take C2H2, which is 230. What's the coefficient there? The coefficient there is 3. So I take 3 times, because it's coefficient times the value, 230. Multiply that, I'm going to get 690. So if I have 690, 83 minus 690, the correct answer for that one is gonna be, let's think about it, negative 607. Key thing to remember when you go to do this, products minus reactants. Whenever you see the delta HF, products on this side, reactants on this side, be sure and use the coefficient there. If you notice the coefficient 3, there's the coefficient 3. I have to multiply the 230 times 3. They're my reactants. This one, the value is 1, so it's just 83. Simple mathematics. You get 690 minus its A. That should be a piece of cake. Next one, 26. If you're going to make solutions, we talked about this. This quick way to make a solution is this. You go molarity that you want. I get right there. Molarity that you want times molar mass times how many liters. That will always get you the number of grams that you have to weigh out. So if they give you a solution question in the multiple choice, it's just molarity times molar mass times liters. The molarity they want is 0.1, so I'm going to put in 0.10 right there. Molarity, molar mass, they're going to tell you the molar mass is 250. So 250, and then the number of liters I need is 0.250. So if you look at the setup right there, it's very simple. It's going to be basically 0.1 times 250 times 0.25. Very, very simple calculation. When you go to do it, think of it this way. If you take a tenth of 250, so this is technically a tenth, whoops. This is technically a tenth. So if I take a tenth of 250, I change this to 25, and then times 0.25, which is a quarter. What's a quarter of 25? It's going to be right around 6.2. So when you go to make a solution problem on the test is molarity times molar mass times liters. Just set it up. You take those 3 numbers, stack them, and there's got to be a simple way to do the calculation. Next one, this is kinetics. Remember kinetics, this is a rate law mechanism. We could base it always on the slowest step, the reactants. So the first thing I'm going to do is go to the reactants to the slowest step. I find the slowest step and I go right there. I always write my rate law based on what's there in yellow. So I write rate is equal to K, concentration of NO, and there's two of them, so I group like terms together, so I'm going to get A. As long as there's no intermediates, the intermediate is N2O2, N2O2 cancels. And everything else drops down in the overall reaction, which you see right there. So you always base the rate law on the slowest step. You go to the reactants, which I highlighted in yellow, copy it down. If it's an intermediate, then you sub up above. But if you got this problem wrong, I'm not sure why you got it wrong. It's pretty simple. 28. They ask you which of the following is an ionic compound. The definition of ionic compound is a metal. It's supposed to say metal plus a non-metal. If you look right here, two nonmetals, two nonmetals, two nonmetals, metalloid, and a non-metal scratch. So really, when they ask you which one is the most ionic, you're looking for a metal and a non-metal. Calcium is a metal, Cl2 is a non-metal. That should be a simple question.